Yesterday we started off with named tuple as collection. So today we'll look at what is called as deck. So deck is essentially also called as doubly linked queue. That is what is deck. So it is also called as doubly linked queue. And one aspect of doubly linked queue is it is a linear data structure. It is a linear data structure, and we can perform operations on both ends. On both ends of this linear structure. Okay, that is what is a doubly linked queue. And so let's say we have something like this, which is essentially representing as a doubly linked queue. Then we can add elements at this end, or we can add elements from this end. So that is how this would look like. So this is our doubly linked queue, and we can perform insertions or deletions from both ends. Okay. And let me try to put some blocks to it so that, it looks like a doubly linked queue. Then adjust it later. Right, so we have something like this. This is how a doubly linked queue would look like. And let me try to bring down the space for this one and then move this up. I think this is looking good now. All right. So this is how a doubly linked queue would look like. We would have elements in them, and we can use a deck for both, can be used for both as a queue and a stack. We'll come back to this topic later once we complete SQL. And if you would like to do algorithms and data structures in Python, then probably we'll try to extend our sessions and try to complete some of the implementations in Python itself. That is what we'll plan for. So for right now, what we'll do is we'll essentially try to build a deck from the collections package. Okay, that is already provided. So how do we do it? We just use this collections package and then import deck. Okay. Right, that is what we'll try to do. So from collections, import deck is what we do. And we'll start using them. So I'll define a function for this. I'll say play with the deck. Okay, and then we'll try to perform some operations here. We'll write our main method. So I would say if underscore underscore name equals underscore underscore main, right? And then we can write our main method here and then try to call this function. All right, so so first thing is we will try to create elements in the deck. So how do we create an element? So I'll try to do this in this particular function called as play with deck. So I'll say, okay, this is what we create as deck, and then d1 dot append of, let's say we want to append few names. So I would say Abhay is what is appended. Then I add few more names. So how do we initialize? We import it. We have already imported it. So I use this deck, initialize this in with this way, and assign it to a variable called as d1, and then d1 dot append, right? And appending a name to it. And then I start appending few more names to it. So I call Akhil, and then d1 dot append of Asutosh. So that is what I'll try to append here. d1 dot append of Vimal. d1 dot append of Chirag. Okay, I've added few names here, and then finally we will try to print the deck, or probably we'll try to return the deck. Okay, that is what we'll try to do here. So I'll say print even. Okay, that is what I do here. So I print this particular deck value and see how this is evaluated. So how do we call this? I call the function play with deck. We're not passing anything to this function right now. So I'm just calling it as it is. Okay, so what we have done is from collections import deck, and then we have defined two functions, one function, and then call our main. And within main, we are trying to call our function play with deck. So let me run this. Okay, so I think the D was not there for the last append that we made. So that is the error. And now we get a deck. So we have Abhay, Akhil, Ashutosh, Bimal, and the Chirag, right? These are the names that we have added. Now, since we have the deck, what I'll do is I'll just comment this out and then return this deck that we have constructed for now. And then try to add an element here. Okay. And then because it is returning, I'll try to store this in a variable called a G2. And then print D2 first. Okay, let's see if this works. So that is what I'll try to do now. So we return this particular deck, and from this function, this is returning. So I store it in a variable called D2 and then print this. Something went wrong. Line 1, why does it say that? And this should be okay. So we got D2. It's supposed to be D2, right? Right, now it is fine. Probably something went wrong there. So this is fine. So D2 is defined now. So we get the deck back, right? So it is being constructed and we get the deck back here. So now that we got the deck, let's see if we can change this deck, okay? So what I'll do is I'll instead write one more function. I call this as, let's say, increase deck. Okay, and then I pass D2 to this, or let's say some variable. Okay, we call this as DEQ. Okay, and then within this function, if you want to add an element, right? Let's say I call this element as name. That is what we can call this as ELE. That would be better. So I call this as ELE. And then we return this by extending it. Okay. There is something called as an extend function. And then I add this particular ELE. We try to add this and then we'll see what it does. Okay, so we have an extend function on this. So I call this and then you can see what it returns. So it is returning deck.ext. Okay, we do not do a deck.extend. So and then see if we return this deck. Okay. Right, so this is what we do here. And then I say print, and within the print, I call this increase deck function. And within this increase deck function, I pass D2. And the element that we have is essentially, say, Taman is what we pass to it. Okay, so that is what I pass. And then let's see what it's printed. All right, so I need to add this as a list because this is the iterable object. So I call this in this fashion and then I run this. Okay, Taman is added. What extend does is it, it accepts a iterable object. So I pass this ELE as a list. So that is what I'm trying to do here. If we are not doing this, right, it added characters, right? Every letter of this was added to it. That is what was the previous output, right? That is why I changed it to a list as an iterable that is being passed to the extend function. So we wrote this increase deck and it is taking an input as deck and another element, right? The element is what we are passing and we are essentially extending this particular deck, right? So an element is added and it is added at the end, right? So it is essentially added at the end and we see this being appended. Now let's say when we are trying to append, we are trying to append it from this side, right? Any deck. So let me try to see if there is a function like append left, right? We have something called as append left, right? So if I do a dot and then type in for the functions or see if there is any function, right, that would be visible here. So we can do an extend left, or we can do an append left. This is something that we have. So what we'll do is we'll try to, append an element on the left side, right? We added it from the right side, right? But this is what we have seen with respect to a deck. We can do an insertion or a deletion from both ends. Right now we have done this in this fashion, right? So we can either do it from the left side or we can do it in the right side, right? So that is what I'll try to do here. So insertion and deletion for this deck can happen from this side or from this side. So all that we have done is from this side so far, which is essentially insertion, appending, and extend happened on this side, right? So we'll try to add this from the left side and see how we can do that. So let me try to do this here, or we can also write a function, but quick to check it quickly, right? I'll try to add something here. So d2 dot append left, okay, and then add an element to it. What is the element that we add? I call this as Banu. Oops, right? Yeah, Banu. So this is what I add to it. So d2 dot append left as Banu. So this is what we have. And we have already added few names. So let's see what it does now. And then finally I print d2. Okay, so let's run this and see what is there in D2. So I'll comment this D2 for now because we want to see what is happening after Daman and Bhanu, right? So I'm just removing this print statement. This would not print it. This would not be printed out now. Okay, what is being printed right now is from this function call already. We had Daman, right? Daman was added, and then we added Chirag because we are extending it. We added this. Where is Chirag? Yeah, it's already there. And then we added Daman, and now we added Bhanu, right? So Bhanu is essentially appended left. So we see Bhanu here, right? So now it is appended to this side rather than this end. Rather than the right end, it is being appended to the left end. That is what we see here, right? So this is how it is getting appended. Okay, so that is how we'll be able to see if the element is added or not. And the other thing that we can do with the deck is also check if we can get values based on indices, right? So let's say I do something like this, d2 of 2, right? Rather than 0, I'll pass 2. There's the index that I'm passing, which is value 2, d2 of 2, and let's see what it returns. And it returns Akhil. So Bhanu is 0, Abhay is 1, Akhil is 2. So it returns as Akhil. That is the value that it prints out. So now the index has been named. Now we know we can access deck based on the index as well. So what we'll try to do is, let's see if we can actually, insert an element at a particular index, right? So that is what I'll try to do here now. So insert an index is what I'll write a function as. So def insert at index. Index and the elements or the argument that it takes is deck. And then we need to pass an index and then the element, right? And that is what I'll try to do here. And then this should return as deck dot insert of, not insert, but I don't think we really need to do that. So let me not do this. I'll just try to say on the deck variable dot insert, and at what index it has to do this, and then the element, right? This is what I try to do this, and let's test this. So now we already printed this. So let me not print this again. I'll comment this out. Now I call insert and index, right? And then if you're not returning it, right? Let's, okay. Let me call this function first, right? And what is the deck that we want to pass is D2. And the name is Chandana. That is what I pass the name as, and that's the element, right? We have to pass the index. Let's say it is at 4. Okay, index is 4, and then I pass this, and then finally I say print of D2. Let's see what it does. Okay, so this is what I'm trying to do is I've done at an index. I'm passing this element and then trying to see if this works. Right now we see Chandana is being inserted at particular index 4, right? So the value has been inserted. So 0, 1, 2, Akhil is at 2, Ashutosh is at 3, Chandana is at 4. So index value 4. Right, so that is what happens. So we need not really return that unless and until it is needed. So it gets inserted and it's in place. That has happened. So now this is what we can do. And similarly, if I want to, insert again, so I say insert at index. The value is D2, which is our deck, and now the element is Mayank. So I use the index 5 now, and then let's see what happens at the output, right? I'm doing 2 insertions and then see what happens. Right now, Chandana and Mayank are there. So we have these values at 4 and 5, right? So it is pointing to the same variable. So D2 is the one that we have passed. So it is still there. And we have inserted this element and inserted both Chandana and Mayank, right? So that is what I have done here. So if we do not want to write this function, you can call directly D2.insert and index and the value, right? This is also something that we can do. Just to show you, if you want to pass an object or if you want to pass a deck to some other function, this is something that we will be able to do, just like list, right? So this is something that we can do. Now, once we have this, we want to remove elements, right? We have seen appends, we have seen append left, right? This is append left. So this is at the beginning, right? Append is at the end. So append was essentially at the end. That is what we have seen. Append adds the elements or adds the elements at the end. And that is what we have seen. And append left is at the beginning. And also we have seen extend. Extend is also at the end. And index or insert is essentially a value that is being inserted at a particular index. And what is the element value for that particular index, right? So that is how we have seen these 3 functions that could be applied on deck. Now, let's say we want to remove an element. We can either write a function or we can just use the function directly here. So let's say I want to remove one element from this and I do not want to name anything. So we have something called as pop. Okay, pop is essentially trying to remove an element from the end, right? So it is not from the beginning, but from the end. So we have Daman here, and then try to print D2 after the pop has been done, right? Or let's say I get the value here, pop, and then print what is it is returning, right? I say ELE here, okay? Or probably we'll have multiple elements. So let me try to name this ELE1 and then print ELE1. So pop is what is returning an element, and then we'll see what it returns. Right, so it prints out Daman here, right? What essentially has happened is it tries to remove the elements from the end or from the other end and or from the right side, right? That is what has happened, and it returns the value as Daman. Okay. So instead of doing this, let's say I want to do it from the left side. So I say D2 dot pop left and then print the element ELE2. And this is what I do. So pop was from the right side and pop left will remove the element from the left side, right? So let me try to print this again. So now it gives us Bhanu, right? And what is there in D2, right? When we say these elements are removed, right? When we want to remove, we have used pop or pop left. And what should be there in D2 once this has been removed, right? So let's try to see this remaining elements in D2. All right, so I use a comma to separate D2. So remaining elements in D2 after these 2 elements have been, popped out of them. The pop is essentially trying to remove from the elements from the right side or the left side. Okay. So once we do this, we see Bhanu and Daman are no longer there in the deck, right? So we have the deck with elements Abhay, Akhil, Ashutosh, Chandana, Mayank, Bimal, and Chirag. These are only the elements that are available. We do not have the elements Bhanu and Daman, right? Because that they have been removed from the deck. And so this is how we'll be able to remove elements. Now, the other way to remove an element is using the element itself, right? So remove an element based on its name. Okay, remove an element using the name. Okay, so that is what we can do. So I would say d2 dot remove and then the name of the element, let's say Ashutosh, right? This is what we have, and then print d2, right? After removing, right? After removing the element. So this is what we will have. So which is essentially D2. Okay, so here we are removing Ashutosh from D2, right? That is what we are trying to do here. Okay, and we have passed the name itself. Previously, we had just used pop and pop left, and now we are using remove. So, let me try to run this, save it, and then run it. Right, so Ashutosh is no longer there. We have Abhay. Oh, let me try to pull this up. And we have Abhay, Akhil, Chandana, Mayank, Bimal, and Chirag. We removed Ashutosh using the name itself. So now it is no longer there in the deck. Right, so that is how we can use it. So if we want to use it as a stack, we can use it as a stack. And if you want to use it as a queue, we can use it as a queue. Probably we have not discussed these concepts, but we'll come back to these concepts later once we complete SQL and then we do classes, right? And if you have time, we'll come back to these. We'll look at algorithms and data structures as well as we go further. Okay, so this is how we can remove an element. So for these functions, probably I would request you to write your own functions. When I say own functions, write functions like this and then pass the deck to it and then do a pop or a pop left, right? Just like we did for increment q or insert at index. Again, internally, it is anyways calling the inbuilt function. We can use these functions anyways, and then, and finally, uh, write our own functions which have the inbuilt functions called, right? That is something that we can do. So that way it will look somewhat better and see what kind of elements are being removed, or if you want to return an element, if you want to kind of return something, then probably we can do that. Or if you just want to pass the deck and then remove the element and we do not want to do anything else, also we can do that. So it becomes a complete collection where all the operations are defined as a deck, but then we are using internal functions. That's still okay, right? We can write our own functions as well. Okay, so that is what is about deck. This is what a deck will look like. We can do the insertions and deletions from the left side and also from the right side. That is what is a deck about, a doubly ended queue, right? So any questions on doubly ended queue that we have seen in the collections module that is available? All right. So if there are no questions in deck, then what we'll do is we'll try to uh, use another collection that we have, which is called as counter. Okay. Let me try to use counter. That is also an object that is available in the collections module. So let me try to create a file for this. I'll call this as exe collections 03.py, right? So the extension that we are using is a .py file all the time. And example for counter, right? That is what we have. And we want to create an empty counter and then we want to use it. So we'll see how to do this. But before we do that, counter is essentially an object to count things. Okay, if you want to count something, is used to count the elements in a iterable object. Okay, that is what counter will be used for. And how do we kind of know it is being used for counting is something that we'll demonstrate in this file. But then how do we use it, right? So the same way we used for deck and named tuple, we call the collections module, and from there we import counter. Okay, we have something called as counter. That is what we will try to import and then start using it. So first thing is, if you want to create an empty counter, so first what I'll do is I'll write a main method for this so that we can execute starting or beginning from the main. So this is what I'll write here. And then we want to instantiate counter. So I'll say this is C1 and then counter, right? And then see what this counter has. So rather than I'll say CNTR, that would give a meaningful name to it. Print, what is happening? Print CNTR. Okay, so that is what I'll try to do here. Then let's run this. Okay, we have imported counter from the collections module. How do we do that? From collections, import counter. And within this main, we are initializing counter in this fashion and assigning it to a variable. And then we try to print this out. Let's see what gets printed. We get an empty counter object in the output, right? That is what we see. So first thing that we will try to do here is we will try to write a simple function and see how do we kind of get the most common elements that are available. So what do we mean by this, right? So let me try to write a function, play with counter. Okay, and let's say we want to pass a string. Okay, we call s1 or str1. This is a string, and then we'll try to implement this. But even before that, let me try to construct the string. So I call this str1. I try to get some data or some string value. So let me do this. All right, I have some text that is available. Okay, so I copy this from here and then put it here. Okay, this looks very odd. So what we'll do is we'll use 3 double quotes, or let me do that first and then 3 quotes, right? Now we add the text in this. Okay, it shows a lot of lines. So first thing is let me try to format it quickly and then we can use this as we want. So some text I have taken. I'll try to remove these empty lines that are available. This is a text that is available in Wikipedia. So I've just taken this text here, and then I run this in this fashion. Let me try to run this. So we have some text, right? There are certain words or sentences that are available in this text. And right? So I have enclosed this in three quotes. So now we have a multi-line text. Now, once I do this, we have str1. So I can pass str1 to, right? I can pass this str1 to this particular function. And within this function, we'll see how to use counter object there, right? So, okay, let me try to comment this out. So we have this empty counter object. So this is not doing anything right now. So just comment that out, and I'll pass this str1 to this play with counter here and see how we can use this. So I want to get words from this str function. Oh, sorry, from this str1 variable. So I call split on this str1 and split based on the space, right? We want to split it based on the space. That is what I have. So I split it based on the space. And now we will use the counter. So I use counter and pass words to it, right? And then I want to get the most common words. How many of them? So let's say most common, and how many of them is probably the 10 most common words, right? So this is what counter of words will give us. Or even then, it would be better. Okay, yeah, let me try to print this out. Print counter of most common 10 words from this string that we have. So we have this string which is consisting of certain sentences, right? That is what we have. And we will be passing this string to this particular function, play with counter, right? And then what we have done is we are splitting this particular string based on space. That is what we are trying to do here. Based on space, we are trying to split it and then store it into a variable words. And from this variable, I'm passing this variable to the counter object, right? So it takes certain inputs, which is basically an iterable. That is what it takes as an input. And then I call this most common. How many most common elements that are there in this particular iterable object, right? So that is what I want to get as the output, right? And about 10. And I then pass this to the print function, which gives us the output. Okay, that is what we have here. So now let me call this particular function, play with counter from this particular place, right? str1 is there, and then we have play with counter, which is taking an str1 input, and then I've split it and then get it into words and then try to pass that words to counter and then find the most common 10 words, right? That is what I have done. So let me call this here and then pass this particular object or this particular string value to this. Okay. And anyways, we are printing the value there. So that should be okay. Now the variables are different. This is in this block, it is str1 and str1 is in this block. So the variables are different. It is not the same. Or if you do not want to get confused, let me call this word text, right? So that we know we are passing a different variable altogether. So I call this as word text. And the variable name is different, and then I pass this word text, right? So now this should be fine, right? So we have these kind of string values within this particular word text string that are most common. The most common is an empty value, then is the new line, right? We have this new line. Everywhere we have a new line after this. So that is why it got printed. How many of them are there? There are 6 of them. And Python is the next common word, 5, and then and then we have is, then then programming, and as, and it. These are the most common words that are available in this particular text. And that is what we have passed this to play with counter, right? So that is what we have done here. And we see this, how it gets generated. Fine. So this is what we can do with most common. Okay, so that is what we'll be able to do with most common. So now that we have this, right, and Now we want to know the top 5, right? Or let's say we do this, right? Or we have this as the list of elements that we have, and then now we want to print out the various elements that it has. So if I do this, let's say counter of words, right? And then dot elements, right? It prints out all the elements that are there in this particular iterable object, right? Counter of words is essentially what we get after we split, and whatever is there in that is what is printed out, right? So that is what would be printed out when we do dot elements. So let me try to run this. Right, it is basically an iterable object. That is what we get. So we have to iterate over this particular word count dot elements. That is what it gives us as the output. It is basically an iterable object. There is something called as iter tools also within Python. Probably we'll cover that later, but not for this basic classes. But then this is what is the output. And then let's say we want to get the output of this, right? So I say word ELE is nothing but this particular dot elements that we have called on counter of words, right? I then comment this out so that it is not printed again, right? This is what we have, and then I enclose elements within empty parentheses, or empty parentheses are provided to the elements, and now it's basically a function call. Right, now we want to know what are the top 5 elements that are available, or the first 5 elements. So what I'll do is I'll simply write a count, and then the num is 5, so that we can iterate over these elements. So for I in word ELE, right? This essentially gives us an iterable object, so we can iterate over this, right? And then I print this element, or we can call this as ELE also. I print the element each time it is iterated over. So I call this print ELE, okay? And then here we increment our count value to 1. Okay, each and every time that it comes over, it increments. And if count is equals to n, right, when it is hitting the value, we call this as num, right, not n, okay, num, then we want to break out of this for loop, right, so that it prints out the top 5 elements that are available. That is what we are trying to do here. Okay, let me run this now. Okay, and let's see the output. Right, so the top 5 elements are basically Python that we see here, right? So whenever we try to do this and we are incrementing it, so the top 5 elements are Python. So if we have 10, then probably we'll see what is elements that we have. So Python and is and right? Whatever we had as a count is what is being printed out, right? So these elements are being printed out, and they are being brought to the front, and that is what is being printed out here, right? That is what we get here. Okay, and if you want to get the total number of elements that are available, right? So I just have to call the total function on this words, right? We pass this counter. We have anyways done this. So we already have the split, and then we have passed this to count. So let me try to change a little bit of this here, and then write this here in this fashion. So I say words C is equals to, or words counter, right? That would be a meaningful name. And then wherever we are using it, I just replace it with word counter. Okay, I remove this word count words and then place it with this particular value, and similarly here, right? This is something that we have done. So elements essentially gives us the elements that are available in the iterable object that counter of words is getting created, and that is what it is printing out. And that is what we are saying. Now, if you want to get the total elements that are there in the counter, total elements in the counter, right? So all that I'll do is I'll say print, and then we have words counter that is already that we have created, and then we have total. Right, so this is what I'll try to do here. We have total that will give the total number of elements that are there in the words counter. Right, this is what we have done. Right, so let me try to run this. Has happened. Something went wrong. Okay. Hmm. So we are passing it here, and then it says while it was iterating over. Doesn't have total. Is it what? Just check. Oh, just total is not there. Just give me a minute. Let me check. And there was total for this to give us the total value. Oh, it looks like it's not there. We cannot find the total value for this. We have most common. All right, looks like there is no total for this particular counter. Right. Which version are you using? Looks like it was added later. So I'm just checking the version that you're using. It does work, but let me try to look at the version that we are using. Uh, Let me try to change the interpreter, right? So it is 3.10, right? So let me try to change the interpreter and let me see if this works. All right, just give me a minute. 3.9 probably that was not there, right? It is there in 3.10, right? That is what it is, right? Is there in 3.10. So let me try to print that out here. So I've changed my interpreter. Looks like this is it was 3.9. So I'm now using 3.10, right? So total, now this works. All right, so let me try to run this now. Oh, okay. So this interpreter is still using 3.9, I guess, but the hmm, just give a minute. What we'll do is probably I'll try to see if this is in Spider. I'm not sure if I'm using yeah, by Spider it is 3.10. Let me try to take this file to Spider and see if this works because the interpreter there is 3.10, and let me try to run this here. Okay. So I've made these changes here. Let me try to run this here in Spider because this is pointing to 3.10. Okay, it says that, okay, this is something that is added here. So I add this from collections import counter and then try to run this. Right, so now it gives 124. Possibly the interpreter still needs to point it to the correct version. Probably I have to change this. The project is not yet loaded. So, right, this was still pointing to 3.9, even though I've used 3.10. So in Spider, if I point it out to, right, because this is pointing out to 3.10, Python 3.10 is what being used. So now I get the total value and you see this 124 being printed out, right? This works as a charm. So the total was added in 3.10. This was not there in 3.9. And now it works here. Fine. So we get the total number of elements that are there in the counter object, or whatever the counter object created as the iterable object, it gives us the total number of elements that are available. Fine. So that is how we'll be able to use total on the on the sorry, this was counter object, right? So that is how we can use it. Right, so it works in the Spider because this is I'm using 3.10, and in Visual Studio Code it was basically 3.9, I guess. So that is why this was the issue. It is not able to recognize the total function that is there. Even though it brings up, possibly this needs a restart before I start using it, right? Let me see this. Right, it does show total, but then it does not. Some of the counts, it does say it works, but then it says this is not having here. This is not reference. The interpreter is 3.10, but let me see what went wrong. But then it works on the Spider ID, right? That is what we have seen. Fine. Any questions on this? All right. So if there are no questions, then let's do the next thing, which is essentially order dict, and then we'll move on to modules and packages. Fine. So let me try to create a new file here. So exec collections 04.py. Okay. So that is what I do here. Right. And then we create what is called as an order dict. Right. So one thing about this is that it is similar to dictionary. Right. It is similar to dictionary. And the insertion order is better in order dict as compared to dictionary. Right. This is what we have. The insertion order is better. And other thing is it can handle the rendering of the elements better than the dictionary. Okay, that is what we can do with the ordered dictionary. Fine. So in order to use ordered dictionary, we use from collections and then import ordered dict. Right. And then here, I'll create the main method. So if underscore name equals underscore main. And this is what I do. And we can create the ordered dict in this fashion. So let me try to create this in this fashion, or let me try to create a function simply and then say def play with ordered dict. And here we are initializing our ordered dictionary. So I say ordered dict is what we have. And then OD1 of Ravi is what is given here. And then I call the department to it. And similarly, OD1 of new. It's a key value pair that we are trying to do it. So that is what I'm assigning a value to the given key. So we have CSC and then OD1 of Kiran. That is what we have. And then this is essentially IT. Right. So this is what we have. We have different values that are being assigned to a particular key. Right. And then I call this. So one thing that we'll notice is that or once I return this, probably we will, or I'll say print even rather than doing that. I'll say just print this. Okay. So I print the ordered dictionary here, and then we see the values that are being printed. Right. We have Ravi, Surya, and Kiran. Right. So this is the order that it maintains. This is what we have as the ordered dictionary. That is what it does. Now we can sort the ordered dictionary by passing something like this. So we can do sorted of OD1, right? And then I print this out. Okay, print sorted of OD1 is what I'm trying to do here. So this gives us the sorted values. Right, we get Kiran, Ravi, and Surya on the keys that we have. So it is essentially doing an alphabetical sorting on the keys. That is when we provide OD1 on sorted, right? That is what we get. Sorted of OD1 is what we get is the alphabetical keys. And now if you want to do this, right? Right. So if you want to iterate over the ordered dictionary, we can call this dot keys, right? And then we can see what it does, right? So for I in OD1 dot keys, print I. So it gives us the value as Ravi, Surya, and Kiran. It is not sorting, but the way it was ordered is what it is retrieving, right? Ravi was the first one, then we had Surya, and then finally Kiran, right? That is the way in which we have passed the values in sequence. Ravi first, Surya second, and then Kiran. So that is what we are trying to do here. So for I in OD1 dot keys, print I is what we get as the values. Okay, so that is what we are printing out. And if you want to retrieve over the values, the same thing that we have done in the dictionary. So we can do this as OD1 dot values. And then we can print out the values. Right. So now it prints out the values here. Okay, we get the values as IT, CSE, and IT. Right. These are the values that it prints out when we do values. Now, if we were to get the items, right? We want to get the items. Items are essentially key value pairs. If you want to get the key value pair, so we say for k comma b in od1 dot items, right? And then we get the keys in this fashion. So I just print out the key is k, right? Key is k in the curly braces, and value is v in curly braces, right? So that is what we get it. So and then I'm formatting it. So we are passing the variables directly to this print statement. Right. So we get the key value pairs in this fashion. So the same way that we try to do this in dictionary is what we see here in the ordered dicta as well. The one thing that we have is that if we want to kind of pop items, right? Let's say we want to pop the items, we can do so. Or if you want to move the elements, let's say to the end, right? Let's say I want to move the elements to the end. Which element I want to use? I want to move the element with the key Surya to the end. Right now it is here in between, but then I want to move it to the end and then try to see the order in which the element is available in the ordered dictionary. So I use move to end. So when we use move to end, it moves the elements to the end. Right, OD1 dot move to end, I pass the element name and then do a print OD1. Fine, this is what I do here. And this is what it does. Initially, it was even before this, like I'll try to print here before we actually do a move to end. So I call this as OD1 here, okay? And then I see what order it maintains. So the first order is Ravi, Surya, and Kiran. And when we did a move to end, it is at the end, and the order now is Ravi, Kiran, and Surya, right? So this is how it is trying to order or maintain the order, right? That is how we'll be able to do so. Right, and then we can pop an item. So if you want to pop an item, so that is something that we can do. So I say item 1 is equals to od1 dot pop item, right? And then print item 1, right? This is what I try to do here. I try to pop an item and then print the item. right? The last element that was there was Surya. So it is what is popped out. That is the element that got popped out. So when we do a pop item, Surya was the last element and it got popped out. And that is what we see in the output, right? Pop item gives us the last one as the one that should be popped out. Fine. So any questions still here? All right. If there are no questions, then we will move to modules and packages, a basic introduction of this, and then we will call it a day. And then we'll see modules and packages tomorrow, and then we'll wind up Python, and then we'll move on to SQL. All right. So let's try to see what is a module. Now, anything that we are trying to write here, right, is basically a module. Any file in Python is basically a module. And this is also called as a script. All right, this is also called as a script. Now, we ran this output from here. And whenever we are running the output, there is an output that is being generated, right? So if I try to run Python file, right? When I click run Python file, we see that there is something that is popping out, right? An exe file, and then it is getting generated. Otherwise, I'll open up my command prompt. Let me also share that. Okay. And from the command prompt, we can also run the file. So right now, the file is at a particular location. And let me try to go to that particular location, and then we'll be able to run it. Let me get that location. Just give me a minute, guys. Or let me do one thing. Let me go to the location and then open up the command prompt. Right now, it is not coming up. So give me a minute. Let me go to that location. Right. So there are different files here that we see in the display, right? There are different file that we have. Now I want to run a particular file. So I use Python, and then to run this file, we call the file name. So I call this something like this. Py. Okay. So this is collection 4. So I use P4 and then try to run this. Oops. Okay. Yeah. I have to go to functions and then I have to do this. Okay. Right. And then try to run this particular file. Right. So it gives the output to the console. Right. I'm in the current directory and then giving the command Python and then the file name. We can either give the complete path of the file or just the file name like this, going into the directory and then calling Python and the file name, right? This gets executed in this fashion. So we can either run this Python command from here or from the place where we are, right? And provide the absolute path of this file and run it, or the complete path of this file and run it, or go to this directory and execute Python and the file name. So we get the output in this fashion, right? We get the output in this fashion where we have the output printed out in whatever way the file was called. Okay, so this is what we are trying to do here. Now, every file that we are trying to use is nothing but a script or a module. So this is essentially a script. This is also called as a script. And that is what we have done here. We have ran the Python script file, which is exec collections4.py. And whatever we ran from the console, we can also do it from the command line using the Python command. Fine. So this is essentially what we are also referring to as a module. Right now, once we have done this, let's say we want to pass certain values to this file, right? We want to pass certain values to this file and we want to know how it could be passed. So there is one module that is available, which we have to import. That is something called as import sys. This is the systems module that we have. I import this and when we call this, the first thing that I am trying to do here is try to get the parameters that we are passing from the command line, right? So I say sys.arg v of 1. What is this 1, etc.? I'll explain. But what we are trying to do is print sys.arg v of 1 and we have imported it. So import sys is what we have done. And now I am trying to do sys.arg v of 1, right? So how does this work is I pass a value 10 here, right? So what is this Python file name? This will be the argument 0 and whatever we are providing after this will become 1. And if we provide few more like 20, that will become the value, or at the index 2, it is the value 20. At index 1, the value is 10. At index 0 is anyways the file name. Now we want to pass certain arguments from the command line. This is dynamic way of passing an input to the file. And using the sys module that is already inbuilt in Python, we can get the values from the command line. So if I do this, right, the first value that was printed is 10. Even before we called our ordered dictionary, the value was 10. Where did this come from? This is the value from the command line. Right? This is what we have passed. Okay. And I also pass the second value, value 1 and value 2. The more number of values we pass using space separated in the command line, or if we are passing the values separated by space like this, then those values can be captured using the sys module and then calling the argv function. Argv is nothing but argument values from the command line, right? So Python file name 10 space 20. Right? Now we get this output. Value 1 from the command line is 10. Value 2 from the command line is 20. So if we want to pass input from the command line to the file, this is how we can do it. Fine. So for modules, right, when we execute them as scripts, this is how we can pass input to the modules or to the file. This is one way of doing it. And how do we import modules? How do we create modules and what are packages is something that we'll continue tomorrow. So any questions, guys, still here? All right. So if there are no questions and if there are no doubts, then what we'll do is we'll stop here and then we'll continue tomorrow. All right, then. See you tomorrow. Bye-bye. Good night.